Namaste, I am Rohan Bandankar, and in this video I'll be dealing with 11 reasons for never ever carrying out the data analysis. I'll be talking about the 11 reasons for which we should not carry out the data analysis. The first reason is reason 1, two questions. The first question is the variable which I have taken lies in which scale of measurement? If I don't know the answer of this question, then I should never ever carry out the data analysis. For example, gender is a nominal variable, and a researcher must know which variable lies in which scale of measurement. Question number 2. What statistical test should I perform in the defined scale of measurement? The nominal variable uses which statistical measure, and these two questions are the fundamental questions that the researcher must answer, and if he or she is unable to do so, then never ever carry out the data analysis. The second reason is the measurement scales. If one have no grasp or no knowledge of measurement scale, then never ever carry out the data analysis. There are four scales of measurement. One is nominal. It is categorical variables with no meaning of numbers, such as gender. If we code the male as 1 and female as 2, then the numbers assigned to male and female has no numerical meaning. That is, we cannot do addition or subtraction or division or multiplication. The examples are gender, religion, occupation. Second is the ordinal scale. It is categorical variables with ranking. It is similar to nominal, but here numbers have some meaning. They are ranked. The best examples are attitude scale, penny scale, Likert scale, and educational level. The third is interval or interval scale. They are numbers with no true zero. The best examples are temperature, time, GPA, and the like. The fourth is the ratio or the ratio scale. The numbers with true zero. Examples are distance, height, weight, income, profit. So, if one have no knowledge of these four scale of measurement, then never ever carry out the data analysis. The reason 3. This is the measurement scale matrix, and this matrix is the basic foundation for the data analysis. And if you have no grasp or no knowledge of these components, then never ever carry out the data analysis. So from here, let's pick one example of the mean, median, and mode. That is central tendency. We cannot find out median or mean for nominal data, and we cannot find out median for the ordinal data. And if one has no idea of these concepts, then never ever carry out the data analysis. The third is the concept of dispersion. Here we cannot calculate any of the dispersion statistics for nominal data. We can calculate range and interquartile range for ordinal data, while we can calculate range, interquartile range, standard deviation, and variance for the interval and ratio scale data. Following this, the region 4, tables and graphs. Never ever carry out the data analysis if you don't have the clear understanding on where to use tables and graphs. If we have the nominal and ordinal scale variables or data, then we, we can use the two-way, three-way, and multiple-way tables. We can draw a bar chart, pie chart, and box plot for ordinal scale data. While for interval and ratio scale data, we can not construct tables, but we can construct the graphs such as histogram, box plot, line chart, population pyramid, scatter plot, and the like. If you are enjoying my video, then please subscribe to my channel so that you can get the you can get the notification as I post a new video. The region 5, deriving the relationship. Deriving the relationship means that if we have two variables, then which relationship shall we derive, or how can we derive the strength of relationship between them? If you don't have the clear idea on it, then never ever carry out the data analysis. If the both variables are of categorical nature, then we can find out phi coefficient and rank correlation. If one is categorical and other is numerical, then we can carry out t-test and ANOVA depending upon the number of categories in the categorical variable. If both the variables are numerical, then we can carry out Pearson's correlation. So these are the basic ideas that one must have to carry out the analysis. Following this, hypothesis. What is hypothesis? Hypothesis is a testable statement which we accept or reject. So to accept or reject the hypothesis, we use t-test, one-way ANOVA, and chi-square test depending upon the nature of variables. If one do not have the idea of these tests, then never ever carry out the data analysis. If the variable is of numerical and categorical nature, then we can use t-test and one-way ANOVA, and this depends upon the number of categories in the categorical variables, such as gender. If I have gender, then there are two categories, male and female, and I have discarded the third category, that is others, or prefer not to say. Then there are only two categories for the time being, so I can use t-test and one-way ANOVA. But if the categorical variable have more than two categories, then we shall use one-way ANOVA, not the t-test. If both the variables are of categorical nature, then we shall use chi-square test. So rule number 7, or reason 7 for not carrying out the data analysis, is the rule of refute. If you do not have a clear grasp of the rule of refute, then never ever carry out the data analysis. Refute your claim or null hypothesis. If p-value or significant value is less than 0.05 or 5%, refute the null hypothesis. Else, do not refute the null hypothesis. Reason 8, concept of z-score. If you do not have the clear concept of z-score, then never ever carry out the data analysis. Z-score of 2 tail 90% equals to z-score of 1 tail 95%. The figure displays this concept more clear. Reason 9. The reason 9 is t-test versus z-test. Do you have the idea about t-test and z-test? Do you know that these two tests are same, but t-test is more valid for small samples, while the z-test is more valid for the large samples, but t-test is also equally valid for the large samples. So t-test and z-test gives same result for large samples, while t-test gives more appropriate result for small samples. So without this knowledge, we shall never ever carry out the data analysis. The reason 10, regression analysis. Regression is basically the approach or the way to find out the impact of independent variable on the dependent variable. This also shows both degree and direction of the relationship. It also shows the causal relationship or cause effect relationship between the two variables. So hovering over this, if we have dependent variable as a categorical, then we shall use logit or multinomial logit. And if we have the dependent variable as numerical variable such as income, then we shall use simple linear regression or multiple linear regression. And for the note section, interpretation of regression coefficient only if the coefficient are significant at 5% and higher R square is preferable. Nevertheless, cross-sectional data have low R square. So while carrying out the regression analysis, if you don't have these basic ideas or this basic knowledge, then never ever carry out the regression analysis. So the last reason for not carrying out the data analysis is causation. Correlation is not causation. Correlation only shows the movement of two variables or the co-movement or the direction of their movements. If two variables move together, they tend to have positive correlation, else there is negative correlation. Spurious correlation, the false sensitivity variables, is evident or it's apparent in most of the cases. So for this you shall refer to the link that I have given in this slide. Unlike correlation, regression is causation as it depicts cause and effect relationship. So without having a clear understanding on what is correlation and what is regression, never ever carry out the data analysis or never ever carry out the regression and correlation analysis. So this is the end of my video, and I request you to subscribe my channel Learn with Rohan, Study Deeper. And if you have any queries, then please ask in the comment box below, and please like this video. And my social networks are, you can follow me in Facebook, personal Facebook, YouTube and Instagram. And if you want to cite this content, then you can cite as given in this slide, and I have given the link of the slide in this description box below, so you can readily download it. Thank you.